How to proceed? First of all, I will explain schematically the steps, starting from the first one to the last one. First of all, complete the initial possible paths with the reverses. Then find the nodes of a path, compare two paths, find all possible paths between all nodes, find all possible paths between two nodes x and y, decompose a path into its paths with two nodes, compute the distance of a path, and finally find the shortest path between two nodes x and y. So totally we will create 8 functions. The first one, initial complete paths. It takes one parameter given paths, a directory object with keys, two nodes, and the values the distance. For example, rp4 sn3. It returns given paths with the round trip paths added. That is, if there is a path AB, there is also a path BA with the same distance. First of all, create an empty directory called symmetric paths. For path in given paths, add the key value pair path colon -1, that is the reverse of the path, with the given paths of the path, that is the value of the path in the given paths directory, to the symmetric paths directory. And then for every key value in symmetric paths directory, add the key value pair to the given paths. At the end, return given paths. Second function, nodes of a path. This function takes one parameter, path, a string object, and appends every odd character starting from 1 to 0th character. For example, if path is A, B, B, F, F, C, C, E, it returns A, B, F, C, E. Parameter is path, it returns nodes present in the path. It's a single line of code. Append all character of path from 1 to the end with the step 2, that is 1 colon 2 to the 0th character of the path and return it. Third function, compare. This function checks two things. Are the two paths connected and the non-presence of the last node of the old path in the new path. The first parameter is new path. The second parameter is old two node initial path. It returns true or false. Compute nodes of a path with the parameter new and assign to nodes in new. Assign last character of new to a variable called last node of new. Assign 0th character of old to a variable called first node of old. Assign last character of old to a variable called last node of old. Compute last node of new is equal to the first node of old and last node of old not in nodes in new. At the end, if it is true, return true, else return false. Generate new paths. It takes one parameter, given paths, directory of path distance key value pairs, returns list of all possible paths. First, compute initial complete paths with parameter given paths and assign to a variable called all given paths dir. Create a variable called all possible paths and assign the copy of list of keys of given paths. And this is the code. Create a variable called initial paths and assign it keys of all given paths directory. Be careful, it's not a list, it's a dict keys object, but it is an iterable. For every new in all possible paths and for every old in initial paths, compare new old. If it returns true, compute new plus old, or concatenate new old to new, and assign to a variable called new path and append new path to all possible paths. At the end, return all possible paths. Find possible paths between two nodes. This function computes all possible paths between the node 1 and node 2. Takes three parameters. The first one is node 1, a string object starting node of the path. Node 2, string object and node of the path. Third parameter, all possible paths, a list object, a list of all possible paths of the network. It returns a list object, a list of all possible paths between node 1 and node 2. First, create an empty list called possible paths between node 1 and node 2. For every path in all possible paths, compute if zeroth character of the path is equal to node 1 and last character of path is equal to node 2. If true, append the path to the list possible paths between node 1 and node 2. At the end, return possible paths between node 1 and node 2. Compose. This function takes a parameter, path, a string object, and return a list of paths with two nodes present in the path. For example, for a path AFFCCB, it returns AFFCCB. It takes one parameter, a path, any path, and returns list of two nodes, paths in the path. First, create an empty list called result. Create a variable called start and assign it 0. For I in range 2 up to length of the path plus 1 with a step 2, compute path with the start argument start and end argument I, and assign to D of decompose. Append D to result, assign I to start, and complete the loop. At the end, return the result. Distance of a path. This function takes two arguments. This function takes two arguments. Path, a string object, and given paths, a two-node path distance directory. It computes the total distance of a given path, and path is a string object, the first parameter. The second parameter, given paths, a directory object, and returns the distance of the path, or in other words, total distance between the initial node of the path and the final node of the path. Create a variable distance and assign 0 to it. Compute the compose path and assign it to a variable called two nodes path in path. For every item in two nodes path in path, compute distance plus given paths with the key item. So the value of the item in the directory given paths, and assign the result to distance. At the end, return the distance. Last function, shortest path. This function computes the shortest distance between two nodes and return a tuple, the shortest path, and its total distance. First parameter, node 1, a string object starting node. Second parameter node 2, a string object, endpoint node. Third parameter, given paths, a directory object, initial path distance directory. Return a tuple object, shortest path, and its corresponding total distance. First, compute, generate new paths, given paths, and assign to a variable called all possible paths. Compute, find possible paths between two nodes, node 1, node 2, all possible paths, and assign to a variable called possible paths between node 1 and node 2. Create a variable called short and assign a big integer to it, for example 100,000. Create an empty string called shortest. For every path in possible paths between nodes and node 1 and node 2, compute distance of a path with two parameters, path and given paths, and assign to a variable called distance. If short is strictly greater than distance, assign distance to short, assign path to shortest, and at the end return shortest short.